How's everybody doing?
Pretty good. That works.
Excellent.
Woo. Awesome. So we're going to make this talk probably a little bit more nerdy than most. So buckle in. We're talking about VMs. VMs stand for virtual machines. I think when the industry first started, we had relatively limited expressiveness within purely Bitcoin. It kind of did very simple things, just moving kind of Bitcoins from point to point. I think Ethereum really expanded upon that with the ability to be Turing complete, making smart contracts. But since then, I think virtual machines have gotten even more expressive. There's different nuances, whether you want to parallelize virtual machines, whether to keep them single-threaded. And so we're going to have a very interesting debate, maybe not a debate, discussing a live podcast, if you will, on talking about different virtual machines. So maybe to kick it off, what's your kind of overview of today's virtual machines? How are you thinking about them? Obviously focus pretty much on the HyperSDK within Avalanche. How are your thoughts today developed from a couple years ago?
Yeah. I think my thoughts today have tilted towards, I really think there's going to be a diversity of different VMs. It's not necessarily just going to be one that's going to win, but if you look back at how programming languages have gone, how different tech stacks have gone, there just always ends up being a diversity of different options to suit different use cases. I think with the ones that we have today, the EVM, Solana, COSM, WASM smart contracts, or Move, which I'm a huge fan of, I think there's a growing diversity now, and I think that some people really seem to think that only one is going to win. I really would bet against that, and that there's going to continue to be more diversity and more different options to suit different use cases, as well as to just suit different preferences. On the HyperSDK side, my focus right now is on building an SDK that enables not just building a new VM, but building a new chain. And that goes into not just what does it take to build one general purpose smart contracting language in VM or blockchain, but also what does it look like to build much more bespoke custom applications. And so to me, I think that there's a huge amount beyond the VM layer itself, or what we talked about with Solana or SVM, Move, and these different options, and also the full stack that goes into the execution. I think actually the line between them is fairly varied. I don't know exactly where you would put it, but there's also the whole, what does the storage look like? What does the data distribution look like? What does it take to agree on it? And parallelization is questionably part of the VM as well. And I think that there's going to be a large use case for purpose-built chains that are making a lot of different optimizations. The way I think about it is, if you're building a Web 2 app, one of the first things you probably start out with is, okay, what data am I working with? And laying out, okay, well, here's the database schema that I'm working with, here's what the read and write workloads are going to look like for me to build my application. And I'm very interested in, okay, doing that for Web3 very directly by building purpose-built chains where you think about, this is exactly the data that I'm using, here's exactly how I want to lay it out, and not necessarily using a default option like the Ethereum Merkle tree where everything is hashed, even if you don't necessarily need that in your workload. So I think there's going to be a lot of potential in customizing the VM where it's questionably even called a VM anymore, at least not in the general purpose sense.
Maybe passing it to you, Nick, why is it not going to be one chain that rules the world? We saw in the early days of Ethereum a lot of magic during DeFi summer. Composability was really cool. And to me, that was really representative of, hey, EVM is a standard that when we use Ethereum, we're all opting into. And that resulted in a lot of cool experiments with DeFi Summer. We saw composability firsthand. NodeKit is obviously allowing some more expressiveness. What are your thoughts around, is one VM going to win? Is it going to be a multi-VM world? How are you viewing it?
Yeah, I mean, we obviously started with the same VM on the EVM. That's where everyone was, just because that's the first thing that was actually built out with composability in mind, and where we all started to get traction around DeFi Summer and things like that. Our kind of stance on it is very similar to you in that we don't necessarily care about what the VM that you're working on is, insofar as like if you're going to try to performance optimize for speed, or if you're going to be more on the security side, or if you want to have, you know, whatever different applications that you're trying to build out your chain to be, whether it's an application-specific chain, or if you have a, you know, a sector that you want to specialize in for your chain, it's important that you're able to customize your VM at that level. But while maintaining the composability that we had when we shared the same chain, when we shared the same VM on Ethereum through the EVM. So EVM itself, as all VMs have kind of taken off recently, it's been, all its shortcomings have not only been like highlighted but pretty beaten down on. And I'm not necessarily anti-EVM. It's just that different people want different trade-offs when they're building out these applications. And so if you have something that wants to be highly performance optimized and like is less on the security side, or vice versa, then you want to have the flexibility to have that in your chain while still maintaining the composability with the rest of the network as you had on Ethereum or on any L1, specifically on the EVM historically. But as we're adding out these different customizations to VMs, who's to say what VM it happens on and if it's going to be on one or multiple different VMs?
And Nick, what if someone came to you and said, great, that's an amazing vision, but what if we just make the VM more customizable? Instead of having N VMs, you have a single VM that is more programmable, more expressive, and as these VMs kind of develop over time, they're more agnostic to kind of some of these specific changes that people may want to do, or the reasons why someone may want to have a specific VM.
Yeah, I think that's always a consideration. The main thing is that in any industry, blockchain is no different. You usually see critical mass accrue to a couple of different solutions. Whether there's one canonical solution that ends up being the end-all be-all for all VMs is like probably unlikely. But at the end of the day, like all VMs that we're currently building on are at least somehow influenced by our understanding of the EVM, or have some relationship or some similarities between them, just because of that's how code is built out. You like start from ground zero and then you try to like copy off different things that you see from different VMs. And so it's not necessarily the case that it's not already like that, but it's just expressed in this is this VM, this is that VM, and we have different ways of like, we express them through this is our VM. But you could also say that we have a very general VM that we're going to push forward and then customize it from there.
Aaron, I think a lot of people would probably agree that Ethereum was a huge innovation in terms of blockchain landscape with the EVM, allowing Turing completeness. But I don't think anybody would also, on the same side of the coin, say that it's perfect by any means. And I think one of the larger bottlenecks has really been around the single-threaded execution. Do you think going forward, are most of the VMs going to be doing parallel processing, or will the single-threaded EVM continue to survive and thrive?
What a great and nerdy question. So actually, I think that the bottleneck is not necessarily that it's single-threaded in terms of executing transactions, but that it's single-threaded when it's figuring out what state it's actually going to need to access. So if you look at a profile of an Ethereum node, most of what you're going to see is that about 80% of the execution latency is taken up by reading or writing the state, as well as Merkleization. And so in the EVM, the problem is not necessarily that we're executing transactions sequentially, but that when we're executing transactions, we don't know what state we're going to look up until we hit that point in the sequential pipeline. So we execute transaction 1 in the block, and we say, okay, well, we need to read this state. We go to disk, wait for it to come back, and then continue the execution, right? If you're not necessarily going to disk, that's not necessarily going to be nearly as slow. And whenever you're optimizing something, you really want to start out with what is the actual core bottleneck. And in blockchain systems today, at least starting with Ethereum, it's very clearly more storage than it is the execution. So what a lot of chains are doing now is parallelizing, but also the major benefit they'll get from that is parallelizing state access. So what we've started out doing with the HyperSDK, and Logan was telling me a lot before about how Sui and Solana do similar things in a little bit more detail than I was familiar with, is pessimistic concurrence and control, but also stating exactly what state you're going to need access to. So in the HyperSDK, the default implementation is you pre-declare exactly what state keys you're going to touch so that we can fetch them from the disk for you in advance. And SSDs, storage systems, are generally highly performant and highly parallelizable. So we can actually fetch all of these in parallel and then do the execution of the transactions themselves very, very quickly. So in general, if that execution is not the bottleneck, there's not as much need to parallelize it. It's much more, we get much more bang for our buck out of parallelizing the state access. We also do use pessimistic concurrence control in the HyperSDK, but at the end of the day, it's not nearly as big of an optimization.
So I always like to ask the engineers the nerdy questions, but then also relate it back to why the fuck should anybody care? What is the product standpoint? And so I'm very curious, what does this ultimately unlock from the HyperSDK standpoint that the everyday user and the audience would actually care about it?
That's a great question. What this unlocks to me is that whenever you're I'm going back to my point about whenever you're building a Web 2 app, you're going to care about the level of abstraction underneath. If you're building a Web 2 app, you're going to care about the database you're using and its internals so that you can write your workload to be performant for it. And I think that this doesn't really exist or is not the case in most Web 3 applications today. So I was talking to a developer yesterday who's looking into building a chain on the HyperSDK and looking at the different trade-offs. And I want to continue to make the HyperSDK more configurable to suit the different use cases that are out there. Because as I was talking to this developer, he was actually in the scenario that he's looking at a state size that's easily going to be less than 10 gigabytes. And with modern hardware, you can easily fit that into memory to the point where you don't really need this concurrency control in the first place. If you can keep the entire state in memory, you can hit his throughput and latency requirements relatively easily, which I think is actually really nice and makes his job much easier. And one of the downsides to using the HyperSDK with pessimistic concurrency control right now is it can actually be very difficult to figure out exactly what state keys you're going to touch. So you can either force this on the developer to figure it out, which I think is probably better than putting it on the users, but if you can just avoid it entirely and still hit the throughput and latency requirements that you want, to me that's an even better trade-off. And so I really like the idea of, can we fit those different use cases and actually build applications in full stacks that fit that product use case? And when you start to do that, you can get even higher levels of optimization to build products that weren't previously possible or won't be as scalable, much more easily.
Nick, do you have any specific opinions about the different parallel processing, how to do it single-threaded or a general NodeKit, or you just say, hey, come build whatever you want, we're unopinionated about it, but we're going to try to stitch it all together in the end?
Yeah, I mean, it's important to note that RL1 that's using the HyperSDK is eventually going to be parallelized because we have a network of chains that are using us for composability between them, and we want to be able to maintain their sovereign block space by having a parallelized block that is each individual chains as well as a shared block space for them to interact across chains. So we ourselves are going to be parallelized, but at the end of the day, for us in the design space, it's less about what each of the individual chains decide to build out as, and more so that they're suiting their needs, and that we just accept in whatever they want to send us and provide the composability from there.
I'm curious today, I mean, Aaron, you mentioned kind of storage access as a bottleneck. Do we have like really any unknown unknowns left in blockchain scaling? Are there hard, like either computer science problems or just hard engineering problems that we need to continue to address? Or do you feel like today with things like HyperSDK, with parallelization, with more throughput, it's kind of just continue on the path that we are?
I think it's actually a lot more product questions than it is technical questions now. It's much more so, what are the trade-offs that people actually want to make? You know, we're hitting numbers of 100,000 transactions per second, and although, you know, that's something that many people will try to brag about, I'll actually say there's a lot of people out there doing the same thing. And I love there was an article written recently about we're all building the same thing, and I would much prefer to say, yeah, that's kind of true, than to say why we're a little bit better.
And is that all the same thing? Do you think it is high throughput? Do you think it's parallelization? What is the same thing that all these chains are ultimately working towards?
I'll say we're all building approximately the same thing with their own little flavor. So I won't try to say we're all building the exact same thing and put myself in a box. But you know, SUI, Aptos, HyperSDK, we're all building on decoupled state machine replication in order to hit a point where we can horizontally scale out. We're doing the same, you know, the design in this space is parallelize everything, batch everything as much as possible. And I think everybody is figuring out the ways to do that, and we're moving towards a very similar space. The biggest questions, and you know, there's still problems to figure out. I think storage is one. We're working on Firewood in order to see how to continue to optimize a high sustained write rate to a Merkle DB. Solana, I think, has made a lot of different product trade-offs because of what people are going to use it for. And I think they've made a lot of the right ones because it's ended up that people didn't care about a lot of the things that they gave up. You know, like Solana, for example, decided to have extremely high memory requirements while Ethereum was talking about we want to run on commodity hardware. And it's ended up that, well, people like using this high-performance system and don't care that much about commodity hardware anymore. And I think they also gave up Merkle trees as well. And today, there's not very many people using light clients. But to me, the question is, what are the good long-term decisions, and how do we support those? Because a lot of the promise about blockchain is verifiability, is, how are you going to use a light client to verify this so that we're not just rebuilding the same system with very similar trust assumptions in a pseudo-decentralized way? The question to me is, what do application builders want to do to differentiate themselves building in Web3? It's how does Web3 actually compete with Web2? I think this is very interesting, and there's a lot of different trade-offs to make around Merkleization, like how are you going to verify the data, what type of hardware is going to be necessary, and that's a question for the people here more so than it is for us. I build infrastructure. I talk to these people and love learning about what they're building, but I'd say the answer is totally unclear.
What are you seeing at NodeKit by allowing some more expressivity, sharing, being able to really build whatever you'd like, saying, hey, do single-threaded, do parallelization, deterministic, optimistic, whatever you want. Are you seeing any differentiations on like the product side of what people are building today, or when people, the engineers, are coming to you, they say, hey, we're still bottlenecked from this infra or this XYZ feature?
Yeah, I mean, the customizability has really allowed for, rather than every chain being a general purpose chain, now you're able to see a flourishing of like sector-specific chains or app chains that actually have the ability to succeed because you join a network of composable chains such that you can share users and liquidity between them. And as such, you don't have to, if you're going to be a consumer chain, you need to build out your application such that it's suitable for consumers, rather than building out your chain such that it's suitable for consumers and DeFi and gaming and NFTs and everything else at the same time. What I will say is the importance of scalability and kind of why everyone's building the same thing is because we all kind of recognize that we need to be able to support the users of the internet scale of the blockchain level, right? At one chain being able to handle all the transactions that are currently happening on the internet rather than on the internet happening on a blockchain. And so while we're agnostic to how people want to express that through the VMs or through the way that they're building their chain individually, we ourselves have to be very concerned about how we're scaling that up, because we need to be able to handle the transaction throughput, the latency that the chains on us require in order to be able to serve their use case, despite the fact that they're building for their use case, our use case has to be scalability. And it's the same thing for any other base layer blockchain like an Avalanche, like Sui, Aptos, in order to support the network that's building on top of them.
Am I pronouncing Sui wrong?
Sui, Aptos?
Sui? Oh man, that sounds so weird.
All the names are confusing. Is it AVAX or AVOX?
I have absolutely no idea, but I'm pretty sure I change how I say it once a month.
Aaron, you mentioned one thing about kind of Solana being more opinionated about, instead of focusing on lower hardware requirements, the Raspberry Pis of the world, they're specifically opinionated about having larger hardware requirements. I think it kind of opens up a broader question in my mind, is the industry historically has very much prioritized lower hardware requirements and specifically focusing on horizontal scaling. And now some of the newer chains have come in and say, hey, this is interesting, but we're going to focus on vertical scaling, having larger hardware requirements. Where do you think at the end state, to your point, kind of thinking more long-term, is it going to be some combination of scale vertically and scale horizontally, or do you think one has a much longer winning strategy?
That's a great question. I think it's going to be both. Hardware gets cheaper and cheaper. I was talking with Kevin the other day, and he's saying, looking at the numbers right now, memory, CPU, storage are all getting faster and cheaper, even faster than Moore's law originally predicted, except CPU, I think. That's slowed down. But if these are all getting cheaper and cheaper, then it's going to get more and more reasonable to have higher hardware requirements, and there's no reason to stick with lower ones necessarily. I think the question should not really be about the hardware requirements so much as what is the barrier to entry for people to actually verify this data, and how is that actually used, right? And if people aren't verifying the data, then that's not really that useful to make it verifiable. And that's why, to go back to the point about, it's more of a product question. And the ones that make those trade-offs that end up working out in the long term are going to be, oh, well, this is how people actually wanted to build products. So I think right now Solana's done well, largely because they made a lot of trade-offs that gave up a bunch of stuff people didn't end up using right now. And that gives them more performance in some ways. And also, I'm very curious how it will go in the longer term if, well, now we do want verifiability and that might be harder to support. And I think that comes down to individual applications. And from the applications that I do talk to, they frequently have very different use cases for what needs to be verifiable versus not. But actually, I'm not answering your question, am I?
No, I think it's a good answer.
Yeah, I mean, to that end, that's kind of the approach that we've taken, is that like the chains that are building on top of us are allowed to have that kind of easier onboarding for verifiability for the validator set that they want to have. And then we on the back end, we have to performance optimize and have a little bit of a beefier validator requirement for our set of validators. But at the end of the day, it's like, at what level do you want to have the verifiability? And then you can decide to have higher or lower validator requirements based on the throughput you need on the L1 level or on the L2 level.
I'm kind of like a broader question to each of you are all of these systems kind of competing? Are they all like engineering platforms? Like we're all competing for devs? Like I would say a larger sum. Is it zero sum in terms of if I get devs, you don't have devs, or is it all kind of like we're growing the pie and different ecosystems kind of contribute to each other, maybe specifically in NodeKit versus like the HyperSDK?
Yeah, I mean, the great thing about one of the many things that I love about what we're building is that the composability or the individual applications and users and use cases that you have on these chains, regardless of what VM they're built on, are composable with the rest of the applications on different chains in the VM. So like initially I would argue that, yeah, if you're building in this VM, then you're like fighting for SVM devs or HyperSDK devs, or you're fragmenting kind of the developer set. But if you still enable the same level of composability as we had when we were all building on the EVM, and then we were able to express our developer preferences through our different VMs, then you're still ending up with the best of the composability that we had, while also suiting your use case.
I think saying that different blockchains are not competing with each other for the sake of we're all being friendly is naive. Which, at the same time, we do make the pie bigger, and I think we are all working in a very open source way, so we all benefit from each other's ideas. But at the same time, yeah, there are a limited number of devs, and we all want to maximize the number of developers and users using these systems. So we're definitely competing, yeah.
As we're kind of wrapping up, I would love for you to have 30 seconds to just show what you're doing. And so, Nick, perhaps going first, why should people care about NodeKit? What are you doing? Why should people be excited?
Yeah, well, for the same reason that composability between EVM contracts on Ethereum was incredibly valuable, and we saw the birth of DeFi Summer and all the wonderful creations that came from it. It was actually so good, in fact, that we had to create a scalable network of chains in order to onboard all those users and decrease transaction costs. For the same reason that composability was valuable on a single chain, composability between chains is as or more valuable, as we now have a scalable way of having composability between all users and liquidity in a network. And one of the ways we do it is through the HyperSDK, obviously, which Aaron is kind of spearheading.
So Aaron, how would you show HyperSDK and get the engineers really excited about what you guys are doing here at Avalanche?
If you're building a purpose-built chain and want to maximize your performance, you will not get better performance in any other way than building your own chain and customizing it to your use case.
Perfect. Well, we'll wrap it up there. Please give these gentlemen a round of applause.